Hello everyone. This is going to be a video about the trig ratios that I'm sure you've heard of, sine, cosine, and tangent, and also what they have to do with this circle that we've been working with so far, talking about arc lengths and angles and degrees and radians and all of that. So what do these ratios have to do with radians and degrees? So first off, if you didn't know, this is the full length of each of these three ratios names, sine, cosine, and tangent. We oftentimes, though, do abbreviate these, especially in the calculator, to sine as an S-I-N, cosine to C-O-S, and then tangent to just tan. And the ratios here each mean different things. Sine is the opposite over the hypotenuse when we think about triangles. The opposite over the hypotenuse. Now if we draw a triangle here, I'm going to draw it this way. So if we draw a triangle, and this is the angle that we're looking for, we would be looking at the opposite over here, and this is our hypotenuse. The hypotenuse is always the one opposite the right angle, and the opposite is obviously just whatever is the opposite side of the angle that you are looking at. So now our cosine, that is the relationship between your adjacent side length and your hypotenuse. So in this again, we would have our adjacent, and we would then divide that by our hypotenuse length over there. And then finally, our tangent is our opposite over our adjacent. And there's actually that name that you've probably also heard of before, which can help you remember which one is divided by which, in which situations. So, toa. So what this is the sine is opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. That's just a long acronym that you can remember just by the name SOHCAHTOA, and that will at least help you remember which one is which relationship. All right, so let's look now at this unit circle. Now we saw this in the Explorer for this week. Let's say that this radius here has a length of 1. That is the definition of the unit circle. It's 1 unit. And so if this is a length of 1, the radius is a length of 1, then we can start to talk about the relationships between certain angles in this. Let's say that we just have a triangle within this unit circle. Let's put the triangle starting from the center point to here, and then it has its right angle, and then its angle comes down to there. What this is actually doing is we're finding this angle here, and you can see the relationship between this picture and this picture. So we've got an angle here. Now we can label its hypotenuse, its opposite. Actually, I'm just going to put it as one letter. So this is going to be our hypotenuse and our opposite and our adjacent. So if we wanted to find out what the angle was here, we could use our radius, which by the way is the exact same value here as the hypotenuse. That is the radius because it goes all the way from the center point all the way out to the end. So we could use our radius there, and we could even just multiply it by the angle if we're given that, and we could find the value of either one of these if we used cosine or sine. Or if we didn't have our angle here, then we could maybe we were given the value here and the value here. Then we could even use the relationship sine, cosine, or tangent, depending on which situation is right, to find the angle. So typically I'm going to give you a problem where you're either going to have the angle or you're not going to have the angle. And if you don't have the angle, then you're going to have at least 2 of these values to make it possible to find that angle. All right, let's do an example here. I'm going to give a situation where we know the angle, and then we're going to find out what each of the values is for the hypotenuse, the opposite, and the adjacent. All right, let's say that we have an angle of 50 degrees, which will be slightly past halfway on this circle to 90 degrees. Now, this is going to hit right here. So that means we've got to drop down our line right here to make sure that it is a right angle. There we go. And we've got 50 degrees. How do we find what the value of this circle, what the opposite value is? So how do we find the opposite and the adjacent? Well, let's assume that this is the unit circle. So what that means is, again, that this length here, from here to here, is a length of 1. But what that also means is that this from here to here is a length of 1, because those are both just the radius. Let's assume that it's the unit circle, so our hypotenuse is going to be 1. Now I can use sine, because that is going to be equal to the opposite over the hypotenuse, which is 1. And this is, by the way, this is not a 0, this is an O. So that is going to be the relationship on the right-hand side of the equation. And let's just make a little bit of room here so that we can put in our degree. The sine of 50 degrees in this case should be equal to our opposite value divided by our hypotenuse. Well, how do we solve this? This one's pretty simple, because we can just divide O by 1, and that's not going to change anything, it's still O. So then we have sine of 50 degrees is equal to the value of the opposite side length. Now I'll pull up my calculator. Make sure that you are in degrees. I'm in degrees, as you can see in the top right hand corner. The sine of 50 degrees is 0.7, and I'm going to round that to 77. What does that value represent? That is the length here of our O, and that makes sense. The radius here is our hypotenuse, and that is the longest length of the side that we can possibly have in a triangle. And it looks like this one is slightly smaller than our radius slash our hypotenuse, so 0.77 makes sense. Let's now find the value for our cosine, which is going to give us our adjacent. Now I will put cosine of 50. We always put the angle measure within that parenthesis that goes with the sine, the cosine, or the tangent. And now let's write out the ratio. The ratio again here is the adjacent over the hypotenuse. So our adjacent goes on top, which we don't know, and our hypotenuse is still just 1. So we can also simplify this. A divided by 1 is just A, and then we can use our calculator. Again, making sure it's in degrees, and that is going to be the cosine of 50, which is slightly smaller than the last value, 0.64, and that is going to be the length of our side A. Okay, now let's look at the other way around. We just went from knowing the degree to finding out the lengths of our sides. Now let's look at the other way around, where we start with the lengths of our sides and we have to figure out what the degree is of our angle. All right, so let's get rid of this because we don't know what our angle is. Okay, let's say that we have an angle here, a triangle, starting again from here, but this time let's go even bigger. Let's make it really, really big angle. So this triangle is really tall. It's got its right angle there. And again, this is the unit circle, so we can assume that our hypotenuse side is equal to 1. Now, how are we going to find our angle? Well, first off, we have to give it a little bit more information. Let's say that the height here is 0.87. It's only slightly smaller than our hypotenuse side. How do we find this angle? Well, what relationship do we have here? If we're looking for this angle here, this would be its opposite. This would be its hypotenuse. Which one of these is going to get us that? Well, the sine, because it's got the opposite and the hypotenuse within it. So we're going to use sine. So we're going to put the sine of our unknown angle, which usually you just use the Greek letter theta. Kind of looks like a 0 with a line through it. And that's usually what we use to denote angles that we don't know, kind of how like x is the typical value or variable for our unknown values. And then we put our opposite over our hypotenuse, and we simplify, which is going to just be, again, anything divided by 1 is just that first value. And we get sine of theta is equal to 0.87. Now, if you remember from geometry, there is a way that you can get rid of this sine, and it is by using the inverse sine function. So this inverse sine of both sides is going to get rid of this sine here, and then it's going to get us a new value on the right. So we're going to take the inverse sine, it's going to leave us with theta on the left side, and it's going to be, what is it going to be on the right side? 0.87. The inverse sine of 0.87 is 60.46. And that is in degrees because, again, my calculator is in degrees, as you can see here. And that is the value of theta. So this angle right here would be 60.46 degrees. Okay, there's that work one more time. We're going to do one more, and this time we are not going to know what the size of our circle is, but we are going to know the adjacent and the hypotenuse. So this one that we're going to see now is not going to be the unit circle because the radius is bigger than 1. Let's not know the radius, but let's know that let's make it upside down a little bit too. Our hypotenuse will go from here to here. That is our right angle. We're going to find this angle, of course, and let's say that we know that our opposite side is 7 and our adjacent side is 5.5. Let's say we know those things. So we're actually in this problem going to find out two different things. We're going to find out what the angle is here and also what the length of this long side is. Let's go with finding the angle first. So if we're finding this angle, this is our opposite and this is our adjacent. Which relationship is going to be helpful with those two pieces of information? It's going to be the tangent because that has the relationship between the opposite and the adjacent. So let's set up that relationship. The tangent of this unknown, we don't know it, degree, that angle there is going to be the opposite over the adjacent, so 7 over 5.5. All right, let's go ahead and do the next step. I'm not even going to evaluate what 7 divided by 5.5 is. We'll just leave that as a fraction. How do we get theta by itself? We have to do the inverse tangent of both sides. The inverse tangent of the left will cross off that tangent, and we are going to be left with something on the right side, which is a decimal or some other value. Let's go ahead and find out what that is. All right, the inverse tangent of 7 over 5.5. See how that's all in the parentheses there? That is going to get our most accurate answer, and it gets us a value of 51.84 degrees. Remember degrees because we are in degrees still. We'll be working with radians a little bit more next week in this. So that would be the value of our angle theta here. All right. We could even use that value to figure out what our length of our hypotenuse is. There's actually a couple different ways you could do it. Some people might prefer to use Pythagorean's theorem, which is totally valid. You use the adjacent and the opposite, and you would just solve for the hypotenuse. If you want to do it that way, that works. The way that I'm going to show here is going to be how do we use one of these relationships, sine, cosine, or tangent, to find out what the hypotenuse is. All right, so let's use, we could use sine or cosine. I'm going to use sine here. The sine of the angle 51.84 degrees is going to be the opposite over the hypotenuse. The opposite of that angle is 7, and the hypotenuse is h. All right, we don't know h. Let's go ahead and use some algebra. Multiply both sides by h. I'll use a different color to show that. We're going to multiply this side by h, multiply that side by h. These are going to cross off, and we're going to get h times the sine of 51.84. Remember, this is just a number here. This is not a variable out front. Sine is not a variable. It is simply a number that we can evaluate, and that's going to equal 7. So because this thing here is just a number, that means we can just divide by the sine of 51.84 as well. So that'll be our next step. Let's divide this side by sine, the sine of 51.84, and we'll divide this side also by the sine of 51.84. All right, that's going to cross off, and then we're going to have h is the only thing left on the left side, and then 7 divided by the sine of 51.84 is going to be on the right side. Let's do that. 7 divided by the sine of 51.84, and that is going to get us 8.90 units. Now, let's make sure that answer makes sense. If h is 8.9, it looks like it's going to be the longest length in our triangle, which it should be, and it's also just slightly longer than this, and that would make sense. So h is going to be equal to 8.9 units. You should get the exact same thing if you were to evaluate it using the Pythagorean theorem and solve for c, but either way is going to work. So that's a brief overview and intro to using some sine, cosine, and tangent to evaluate for different angles and different side lengths in our unit circle. You can use this knowledge now in the notes that you took to go ahead and do some of those practice problems on our week 8 practice.